Hi guys, today we are doing grade 12 paper 1 and we are looking at the November 2025 paper question 6, which gives us a straight line g of x is equal to x plus c here in blue, and we are also given a hyperbola, right, which I'm doing in pink, and that's going to be a over x plus p plus q, right? And q we know is our horizontal asymptote there, where y is equal to q. So the vertical asymptote is going to be, the student has put here p, but we know that it's going to be x is equal to minus p, right? And just a reminder about that, because remember that our general form of the hyperbola is a over x minus p plus q, where p and q are our intercepts of our asymptotes, right? So we know it would be x is equal to minus p and y is equal to q. So already they made a little bit confusing there by making it a over x plus p plus q. So that we just have to get straight before we answer anything. So question 6.1 says write down the coordinates of the x-intercept of g in terms of p. All right, so we can see the x value there is going to be negative p, right? So there, I'm going to do it in green here. So that point there, you can see that x value is negative p because based on the horizontal asymptote, right? A vertical asymptote, I beg your pardon. And then obviously the y value is 0. Okay, now we also are told that graph G intersects the horizontal asymptote of the graph at x equals 1. So quite correctly, the student has put there the value of 1 and something, right? But that something, that value there, we can see the horizontal asymptote is q. So we know it's actually that point is 1 in q. We are also told that the graph of f intercepts the graph at f at x equals 3, right? So G intercepts F, right? So pink intercepts blue at 3, right? So there it is there, 3 and something, right? Okay, so question 6.2. We know that g of x is equal to x plus c, right? That's a straight line. We already know that. So what I want to do is just figure out what c is, because c looks like it's going to be equal to p. But we obviously do need to show that, and so let's do that. So we know that this green point here, we've figured out to be negative p and 0. So let's just put that in there, negative p and 0, right? So that means that if we say that g of x is equal to x plus c, we could substitute x is equal to negative p into here, right? And we know that that's equal to 0, right, based on this green point. So why did they give us 6.1? So I always look at, if I have to work out something in 6.1, I'm almost certainly going to have to use it in order to do what I need to do in 6.2. So we know that 0 is then equal to negative p, right, plus c, right? So we're substituting in this point into g of x. And so we get p is equal to c, right? Okay, so now every time we use a c, we can just do p. And that is because they want the graph of g, they want the graph of f, right? They want the graph of f of x. So at no point do we need c for f of x. So if we now know that just p is equal to c, we can now go ahead and every time we have to put in c, we're going to put in p instead. And that's going to get us closer to this answer. Okay, so let's look at what they tell us. So they tell us that at x equals 1, is where it intercepts the horizontal asymptote, right? So we then know that g of 1 is equal to x plus p, right? So g of 1, so let's put that in blue. We know that g of 1, right, the blue one, at 1 is equal to x plus p, right? But we can replace the p, the g of 1, we can replace the 1 with, we can replace the x with a p, right? So we can say negative 1 plus p, right? So what have I done there? I've simply just said, what is g of x at 1, right? What is g of x at 1? Because we know that at 1, at this point here in brown, let me just put this in brown too. So what I'm saying is here, I'm looking at that brown point, right, where x, well, it's like a dark red, where x is equal to 1, right? That's what I'm referring to. We know that g of 1 is equal to 1 plus p, right? If I simply just substitute in my x value of 1, and we also, we know that that is equal to q, right? Because it's equal to the, we're at the brown point, it's equal to the horizontal asymptote, right? So we know that that is actually just equal to q, right? So at the brown point, we see orange right there, horizontal asymptote equaling the blue. So all I do is I substitute in 1 for my x. And so I get an equation which I can use. So let me just do this in white so we keep our equation. So equation 1, we know that q is equal to 1 plus p, right? Q is equal to 1 plus p. Okay, now let's look at the green, the dark green, right? Where they say that blue intercepts pink, right? At x is equal to 3. So we know then, let's do this the dark green so that you guys know which one I'm talking about. So at x is equal to 3, we know that g of 3 is equal to f of 3, right? So g of 3 is equal to f of 3. Now, this would not take you as long in the exam because you wouldn't have to be switching colors. But I'm doing this because I want you to understand what's going on so that it doesn't just look like, okay, what is he doing here? So trying to use colors to make it a little bit more sense. So now we can actually, for g of 3, we can actually just put in 3, right? By the way, if you get a question like this, when they give you information and you think, well, I'm not going to be able to get this, that's okay. What you can do is you can just say, well, I plan on getting some method marks. So I'm going to just put in what g of 3 is because they do tell us that that is important. So g of 3 we know is equal to 3 plus c, right? And we know that f of 3 is equal to a over 3 minus p. Wait, where's the pink one? I should write it here. It's going to be plus p. Okay, so let me just write in pink here. F of x is equal to a over x plus p plus q. So we can refer to that. Okay, so that's plus q, right? So these two are equal to each other. So we can actually now say, and I'm going to do this in, I'm going to keep this now in white because I want my equations to be in white, the important ones, right? So 3 then plus p, oh, yes, c. C we must always write now we're going forward as we know p is equal to c, right? So I'm just going to say which equals 3 plus p. Are you happy? Because of the, over here, right, p is equal to c. Okay, so I'd probably say, therefore, 3 plus p is equal to a over 3 plus p plus q. Okay, but now we know q is just 1 plus p, right? So we can actually just put 1 plus p there instead. So 3, so now from 1, right, we can say that 3 plus p is equal to a over 3 plus p plus 1 plus p. Right, so let me just put that in. So this here is what we substituted q for. Okay. In yellow. So that refers to number 1. Okay, so now we have nothing but p's and a's, which is great. So we can then say that a is equal to 2 times 3 plus p, which equals 6 plus 2p, right? So we have another equation here. I'll make that equation 2. Okay, now when this video renders, it may cut some stuff off. So I'm going to say, for that second equation, I'm just going to repeat it up here. A is equal to 6 plus 2p. Right, so I've got equation 2 there and equation 1. So equation 1, Q is equal to, but that's not so important because I've already used equation 1. Okay, so now what else? They did give us something else. They also gave us another point where they equal, and that was at C, isn't it? So this is at x equals 0, right? So I'm referring now to where at x is equal to 0. Okay, we know that f of 0 is equal to g of 0, don't we? So let's go back to our colors. So we know that f of 0 is equal to g of 0, right? So now we can simply sub in values, can't we? So when we sub in 0 into our f of 0, we simply get, into our g of x, we get 0 plus c, but now we know c is p, right? So for this one, I should have done this in the dark, and this is, I've been doing this should be a darker blue here, okay, f of 0. So this is g of x. So that is going to be p, because 0, I'm just going to say plus c, because I'm going to have an extra line. Therefore p, right? So it's going to be p equals, because we know that p is equal to c. G of 0. Now g of 0, we substitute 0 into this into our f of x, right? So g of 0 will be a over p plus q. Okay, but now we do know that q is equal to 1 plus p, don't we? So we can say well, we've got these two equations. So actually I am going to write the other one up here. So equation 1 and 2 are what we're going to use. So equation 1 was, I'm just going to delete this part now because it's not so important. So I'm going to take that away because I'm going to just now put our equation 1 back up here. You don't need to do this, but I'm just going to do it so that you can see which equations I'm using. So I'm using Q equals 1 plus P. Right, so these are a lot of simultaneous equations, but I'm narrowing it down now to get less and less letters. Okay, so we know that Q is equal to 1 plus P. And we know that A is, so we got P. I'm going to drop the colors now. Now A from equation 2 is 6 plus 2P, right? Over P. And then Q we know is 1 plus P. The more I'm doing it, the more I'm thinking how difficult this question was for you guys. So yeah, if you got it, super well done. So I'm going to times through by P to get rid of the P on the bottom. So P squared is equal to 6 plus 2P plus 1 plus P squared. The P squareds go away. And I get 6 plus 2P. That's an odd number. What have I done wrong here? 6 plus 2P plus 1 plus P equals P. 6 plus 2P plus, oh, this is 2 here. Because it's 6 plus 2P. No, this is P here. Because we times this by P. We can't be left with a 1. That must be P there. Okay, I'll just explain to what I did here quickly. So this is a P here. Okay, because what I did was I replaced this Q with a P plus 1. With a 1 plus P. And then when I times everything by, so this is 1. Yeah. But then when I, so the second one here, so when I times everything by p, this becomes a p. Yeah. Okay, now I'm not going to get an odd number for p. Yes. So now this will work because I'm going to get the p squareds cancelling. And 2p plus p is 3p. And so I'll get 6 equals 3p. And p is equal to -2, which I want. I do want that. Because, yeah, this is making sense. Because you've got, this is x equals negative, x is equal to 2, right? Because what is p? If p is -2, x is equal to -p, right? So therefore x would equal -2 times -2. Right? So negative, oops, what have I done here? Hey, what's going on? Negative -2, right? Negative, because p is -2, giving us 2. That makes sense because this is 1 here. The x value of the brown thing is 1. The x value of the green thing is 3. And so this is 2, which we knew intuitively, but we had to prove it. And so now that we've got all the simultaneous equations, we can actually finish this off, right? So if p is equal to 2, right, we also know that q is equal to 1 plus p, right? So q, I'm going to do this in orange because I like to. Q is equal to 1 plus p, that's equation 1. And we now know that p is -2. So we know that q is equal to -1, which makes perfect sense, right? Because we have y is equal to q, so y is equal to -1, and that is indeed shifted down by 1. So yeah, we've got that point here because it's okay. And then what else? So we've got q, we've got p, we need a. A is 6 plus 2p. So we know that a is equal to 6 plus 2p. Just running out of space, I'll have to do it here. So a is equal to 6 plus 2 times -2 because p is -2. We get a is equal to 2, which makes sense. It's got to be a positive value because it's in the quadrants 1 and 3. So our final answer for 6.3, after all that work for 5 marks, wow. I would have definitely, if you're thinking of time management, not spend too much time on this question. There will be, when we do this, and guys, please subscribe. I'll do the rest of this paper if there's enough interest. So comment if you'd like me to do the memo for the rest of the paper. Maybe just tell me what questions you struggled with, and I'll start with those first, because this was sent to me by a student who found this one of the trickiest questions, so that's why I'm doing it. So yeah, send me a comment, link, like, subscribe, all that good stuff, and then I will happily oblige and send you the rest of this stuff. Okay, so a is 2 x minus p, so that'll be -2 plus q, which is -1. And there is our final answer, making sense. Okay, now describe, 6.3 says, describe the transformation that G must undergo to become an axis of symmetry of F at the 2 points. Okay, so when I show guys what the axis of symmetry is, how to do it, what I like to do is I simply highlight where you get it from. Okay, so you're going to get it from, what color have I not used? I haven't used purple. You get it from, okay, well, that's pink. Purple. You get it from here, and it's then, I'm going to just do this in black. So the axes of symmetry are going to be y equals, I'm going to write it above here. Okay, so you can write this in, so this would be for 6.3, we do it up here. You could say y is equal to plus or minus x plus, so this part here plus p, but we've got it to be x minus 2, right? So x minus 2 minus 1, plus or minus. Now, what I'm going to draw in purple the asymptote, the axis of symmetry that we need, which is the positive one, right? The one that cuts the pink graph, the hyperbola. So that's going to be going like this, right? But we know that it has a gradient of x, so it's actually parallel to. It's actually parallel. It doesn't look parallel. It looks okay. I don't know if you can see that, but it's parallel to g, so it's just a downwards shift. How much is it going down? Well, let's get the function. So it's going to be, so we know the function that it wants to become is going to be the positive gradient, right? So it's going to be y equals x minus 2 minus 1 will be minus 3. Well, what have we got? So 6.2, the transformation g, well, it's g of x is equal to x minus 2, right? So 6.3, we know that g of x is equal to x plus c, right? And we know that c is equal to p, and we worked out p to be negative 2, right? So g of x is equal to x minus 2. I think that would be good for 1 mark. The memo is going to be a while before that comes out. But yeah, stick around here. I'm going to do these, and it would be great if you do it too. And if you find I've made a mistake, that would be fantastic. So yeah, I'd love to do the rest of these questions, and I will put them up. So yeah, as I said, like, subscribe, comment, and then I'll do it. So, but it has to become minus 3, right? So it will need to be, then g of x would need to be, it'll be g of x negative minus 1, right? Because if I take 1 off the 2, it becomes a minus 3, which is what it has to become. So it needs to, 6.3 must shift down by 1 unit. Okay, right, that was fun. Okay, so guys, thanks very much for watching. I hope this helped, and I will see you in the next one. Cheerio.